So the topic for today is binomial theorem. So binomial theorem is a tool in mathematics that we can use in order to expand some very large expressions. For example, if we were to expand a plus b whole squared, then we know that it's a square plus b square plus 2ab. And similarly, we can write the expression for a plus b whole cube, and that is a cube plus b cube plus 3a square b plus 3ab square. These expressions we know by memory because we use them very frequently. But what about larger expressions? For example, a plus b to the power 10 or maybe to the power 12 or 20. It's not very easy to memorize all of these expressions, and the powers may even reach thousands. So we might need to manipulate such expressions and solve them. So for handling these type of situations, binomial theorem is a very useful tool. So I assume that all of you would know the definition of binomial theorem. So here is the Pascal's triangle. I have opened the NCERT solutions with me. This binomial theorem. Yeah, so this is the definition for binomial theorem, as you can see. So I assume all of you are familiar with this. So now we would be moving on to the NCERT solutions. Before starting with the solutions, I would like to introduce myself. I should have done this earlier. My name is Vaibhav Agarwal. I am a computer science student and at IIT Hyderabad. I am pursuing my BTech and I am in my second year right now. And I hail from Ghaziabad, India. So I think we should start now. So about the topic, just so the prerequisites that all of you should at least know is the basic expression of the binomial theorem, which I just showed you, and basics of the C notation. The C notation is nothing but NCR. So if we go here again, yeah, so a plus b to the power n is NC, not a n plus up to whatever. So this expression is something which all of you should be knowing. So I think we can move on. So let's begin from the first exercise. So expand each of the expressions. So my approach would be to give you the intuitions behind the solutions, because that is what really matters to you. The solutions exactly can be found anywhere, but the intuition behind the solutions and the approach, that is what we'll be mainly focusing on in this. So so basically questions 1 to 5 are similar in their approaches, that whenever we are given to expand these expressions, so we just have to apply the basic expression of the binomial theorem that we just discussed, and applying it and just expanding this bracket would basically give us the answer. So that is how we can basically solve questions 1 to 5. The approach is similar in all the questions, and these are not very difficult. So we should move on to question 6, where things start to get slightly trickier. So here I'll just write that use the expression for binomial theorem. So for question 6, so now the question asks us from question 6 to 10, basically all of these are the same theme. So these questions ask us to find out, evaluate these expressions using binomial theorem. So one peculiar thing that that you should notice, or one observation that we should make in all of these questions 6 to 9, I think, yes, 6 to 9, the observation is that all of these are very close to a power of 10. So for example, 96 is 100 minus 4 and 102 is 100 plus 2. Similarly for the others. So if we can write for the first question, so suppose for question 6 we write, suppose 96 cube, we can write it as 100 minus 4 cube. I hope everyone agrees with this. And then we can write this as then we can basically apply the expression for binomial theorem again. So this would basically be equivalent to a minus b cube, where a is 100 and b is 4. And you can use again the expression for the binomial theorem to evaluate this, and hence we can evaluate 96 cube. in a different way than standard multiplication. This similarly, like let us try to solve another example. So suppose we have let us take question 8. So here we have 101 to the power 4. So as you would have guessed, we can write it as, and this is again equivalent to, a plus b to the power 4, where a is 100 and b is 1. So this way we can do all of the questions from 6 to 9, and here will be the approaches for these questions. So I hope it would be clear to all of you. Moving on to question 10. In question 10, we are asked, using binomial theorem, indicate which number is larger, 1.1 to the power 10,000 or 1,000. So a very good approach for this would be to write it as, suppose we were to write 1.1 to the power this. This we can basically write as 1 plus 0.1. I hope you all agree with me. Now, the thing to notice here is that let us write down the first two terms of this expression on the right hand side. So this would give us, we can write the first two terms as follows. So the first term would be 1 plus this times 0.1 plus. Now, as you can see this, or let us write this in a more understandable way. As you can see, I have basically written the first two terms of the binomial expansion of this with and this dot dot dot. Uh, these represent the further terms, and we know that these would basically be positive. So the key observation is that the remaining terms represented by the eclipse by are all positive, because we know that in this expansion 1 plus 0.1 to the power 10,000, all the terms will be positive. There'll be no negative terms. So if we were to just write the value of this term, so what we've expanded here, so we can write it as this would basically be, so 10,000, see 0 is 1 and 0.1 to the power 0 is also 1. So 1 plus equals to 1 plus, and the other term is 10,000 into 0.1. So this is basically equals to 10,000. This is basically equals to 1,001. So so this is greater than. So as we can see, the uh, the value of is greater than 1,001, and which is definitely greater than 1,000. So hence we can say that 1.1 to the power 10,000 is definitely greater than 1,000, and hence we could use binomial theorem to make this deduction. So I hope the approach would be clear to all of you. The intuition behind this was again seeing that the first term of the binomial expansion would be 1,000, and hence and since all the terms are positive, hence the left side must be greater than 1,000. So let's move on to the next question. Question 11. Find a plus b to the power 4 minus a minus b to the power 4. Hence evaluate this. So this question is nothing but we have to apply the binomial theorem on both the for both the things, like root 3 plus root 2 to the power 4 and root 3 minus root 2 to the power 4. So the key observation here is that notice that in root 3 plus root 2 to the power 4, or let me write it down. Notice that all the terms would be positive in this, but also notice that, notice that in root 3 all the terms would not be positive, but the the terms with odd powers of 4 root 4 would be negative. and hence and they would have the same absolute value. All the terms in root 3 plus root 4 to the power 4 and root 3 minus root 4 to the power 4, they'll have the same absolute value, but the terms with the odd power of root 4 in the second bracket, root 3 minus root 4 to the power 4, will have a negative sign in front of them, and hence the positive and negative terms from the two brackets would get cancelled, and um, hence we would be left only with the terms with the of the even powers of root 4, uh, twice twice of that, because uh, all of the other terms would cancel. Hence the final answer is would contain only terms with uh, even powers of even powers of root 4 multiplied by 2, because they would be contributed by both the brackets. So hence we can easily solve this question. I hope everyone is clear with this. So moving on to the next question, question 12. Find x plus 1 to the power 6 plus x minus 1 to the power 6. Okay, I think in the previous question we did a slight error. So there is a minus sign, but notice that there's a minus sign between a plus b to the power 4 and minus a minus b to the power 4. Hence, uh, the term would only contain the terms with this would only contain terms with the odd powers, because the even powers, they would have the same sign, and hence they would get subtracted and they would be cancelled. But the odd powers, minus minus will become plus on the from the second bracket, and hence we would have only the terms with the odd powers of root 4 multiplied by 2. I'm sorry for the mistake. Okay, so I think it would be clear to all of you. So summarizing again question 11, just to solve all the confusion. So root 3 plus root 4 to the power 4, this would have all the terms positive, and root 3 minus root 4 to the power 4, this would have the terms with the odd powers of root 4, they would be negative, only this. But since it has a minus sign in front of the second bracket, so therefore the positive terms from the second bracket would get cancelled with the positive terms from the first bracket, and the final answer would only contain terms with the odd powers of root 4 and whole of that multiplied by 2. So moving to question 12. Question 12 is very similar to the 11th question. In fact, we had earlier solved question in 11. So we had earlier just solved this exactly. So we have a plus sign between the two brackets, and therefore the terms with the odd powers in the second bracket would have negative sign, and they would thus get cancelled by the odd powers from the first bracket, and therefore the final answer would only contain the terms with even powers of even powers of the in this case 1. So yes, that would be our final answer. So I think this is very similar to 11th question, and hence we should skip it. So refer to question 11. Okay, it was root 2 here, just it's root 2 and not root 4. Yes, so moving on to question 13. So question 13 is a we have to make some observation in this question. So notice that we have to find out that we have to show that 9 to the power n plus 1 minus 8n minus 9 is divisible by 64 wherever n is a positive integer. So the first intuition here is to see that 9 is very close to 8, and hence we should have some we should have a motivation to use binomial theorem in this situation. So what if we can write down our initial expression 9 to the power n plus 1 minus 8n minus 9 as 8 plus 1 to the power n plus 1 minus 8n minus 9. We can write it like this, or even better, we can write it as minus 8 minus 1. And then maybe we can write what else can we do? So basically, if we were to expand so here we have a term 8 plus 1 to the power n plus 1. Notice that if we were to expand this using binomial expansion, so the only term that would not contain a power of 8, no, that would contain a zero power of 8, or would not contain a non-zero power of 8, will be the first or the last, whatever you like to call it, the term which would have only one. So basically it would be so in the binomial expansion, the binomial expansion of the first term, which is which is 8 plus 1 to the power n plus 1. The only term with which does not have a non-zero power of 8 is 8, 0 and 1 to the power n plus 1. I hope everybody understands this. This has a 0 power of 8, and therefore this term and this term individually, this term that we're talking about, is not divisible by 8. But note that the value of this term is exactly 1, and thus the one that we obtain from the expansion of this term can get cancelled with this one. So and therefore we can write, yeah, so we can basically write as sum the above equation as sum 8 times k, where k is any number. So basically all the other terms would be divisible by 8 because they have a non-zero power of 8, and therefore we can write that it's just a big number which is divisible by 8. So 8 into k plus 1 minus 8, and this 1 is coming from the term which is not the term from the expansion which is not divisible by 8. So 8k plus 1 minus 8n minus 8 minus 1, and this you can write it as 8 into k minus 8n minus 8. This you can write as 8 into k dash, where k dash is equals to k minus n minus 1. Basically, we know that the final thing, this whole expression is divisible by 8. So with this, we at least know that this expression is divisible by 8. So now we are left to prove that k minus n minus 1 is divisible by 8 also. This is what we have to show in this. So how are we going to show this? Yes, so note that, so this was to show that this was divisible by 8, but we have to show that it's divisible by 64. Hence, we must take into account more terms in the binomial expansion. So if the question was just about to show that the expression is divisible by 8, but now to show that it's divisible by 64, what we can do is we can take another term in the expansion. So basically in the binomial expansion, so taking this equation again that we have written, taking this equation again. So now we consider the two terms. Now we consider two terms of the binomial expansion and write the first term from above as. So if we were to write it, we can write it as follows. So okay, 8 plus 1 to the power n plus 1. This we can write as plus 8 into some k. So where k is again, sorry, this would be 64 into k at this point, because all the terms except all the terms would have a power greater than or equal to 2. A power of 8 which is greater than equal to 2, because the power 0 and 1 we have just taken them out, and hence the rest of the terms would have at least a power of 2 of 8, and therefore they would be divisible by 64. So now since we have written it in this way, and we can further just simplify it to write equals to 1 plus, this is 8n, because n plus 1 cn would be 8n plus, because n plus 1 cn would be n plus 1, and 8 to the power 1 is 8 and 1 is 1. So we can write it in this way, which is equals to 1 plus 8n plus 1, which is 8n plus 9. So now we can just put this 8n plus 9 plus some 64k. So if we put this back into our earlier expression, so we can write substituting in the original expression we get. So we get that 9 plus 8n would get cancelled with So here, if we substitute, so -8 and -9 would just get cancelled with this, and we get 64 into k as the final left, as the final as the leftover expression, which we know is divisible by 64. So here we discussed, basically we solved more than what the question asked. So first we solved that the expression was divisible by 8. Then we showed that the expression was divisible by 64 also. Even we did not need to do this. So basically need not be done. So this was just shown for so that just so that you know how to solve it. So when we have to show that it's divisible by 8, so our approach is to separate out the term which is not divisible by 8 and somehow try to adjust it with the other terms. When we have to show that it is divisible by 64, we have to find out the term which is not divisible by 64 in the binomial expansion, which turned out to be the first two terms of the, or the last two terms, whatever you like to call it, in the binomial expansion, and try to adjust them with the other terms. Similarly, if we were asked to solve it with, suppose with 8 cube, which is 512, then we would like to, well, then we would have separated the three terms, and all those three terms would combine, form the part of the binomial expansion which is not divisible by 512, and so on. So we basically have to separate some terms and try to adjust them with the other terms. That is the basic approach. I hope this would be very clear to all of you. So now moving to question 14, prove that this expression, the summation, is equals to 4 to the power n. So you don't need to actually solve this question in any manner, even though it looks a little daunting. But if you notice very carefully, then we just have to, so let's try to rewrite the question. So the question tries to say r into, just write summation over r for short. You know that it ranges from, say other question say something like this. We can write NCR as CR for short. So what's this? Yeah. So this you can basically write as into 1 to the power n minus r. Notice that we can write it as write it like this because we can always multiply 1 to any expression to and its value won't change. So now you should be able to see a familiar form of binomial theorem, and hence we can just directly write this as coming from the binomial theorem, that this is 1 plus 3 to the power n, which is 4 to the power n, and hence we have done this. So the key thing to note here was that we can multiply that we can just multiply this by 1 to make it in the form of binomial expansion, and thus that was all that was about this question. Okay, so moving to the next question, miscellaneous exercises. So let's try to solve question 1. So if a and b are distinct integers, prove that a minus b is a factor of a to the power n minus b to the power n whenever n is a positive integer. So this question on itself is a little tricky, but we are given a very useful hint for this question, which is this. Write a to the power n as a minus b plus b to the power n and expand. So let's try to do it this way. Let's see what happens. So we have to prove that a minus b is a factor of a to the power n minus b to the power n. So let's try to write a to the power n minus b to the power n, and we'll just follow what the question advises us to do. And we'll write a to the power n as a minus b plus b to the power n minus b to the power n. Yes, so now that we've written it, let's try to expand the first bracket, and it would be something like, so let us just divide it this way, and we write, so it would be very difficult for me to write the whole binomial expression this way, but as you can see, the only term which would not contain, let's move this down. So the only term in the binomial expansion of the first term, that of the bracket, that would, let's write for eliminating confusion that we're talking about, that would not be divisible by A minus B would be, of course, you know it. So NC0 A minus B to the power 0 and B to the power n. I hope this is clear to all of you, or maybe I should. It does not make a difference, but okay, for the sake of notation. So yeah, so this is the only term that would not be divisible by minus b, because all the other terms would have at least one as the power of a minus b in them, and therefore they would be divisible by minus b. And now that we have separated the term which is not divisible by a minus b, and this term would basically be equal to b to the power n, because ncn is 1 and a minus b to the power is 0. A minus b to the power 0 is 1. So hence this term equals to b to the power n. So as we discussed in the previous question as well, so our approach should be to separate out the terms which are not divisible by, in this case, a minus b, and try to adjust them with the other terms. Here the other term is just minus b to the power n, and this can very well adjust. They'll just cancel out, and hence the whole expression, which cancels out with the second term of the expression. Thus, the whole expression is divisible by a minus is divisible by a minus b, and hence we have very easily solved this question. This had nothing. This once we use this hint, then it is basically very similar to question 13. So I think everyone would be clear with this. Question 2, I think, is also very similar to what we discussed for question 11 in the earlier exercise. We just have to expand the terms and keep in mind that some terms would get cancelled. In this case, the terms with the even powers of root 2, the terms with the even powers of would get cancelled, and we can easily solve this question. So let's move on to the next question. Find the value of a square plus root a square minus 1. This question can also be solved very easily using approaches similar to what we did earlier, but the question is that can we do something? I saw something, nothing. So yeah, so this question can also be done very similarly to what we have done for the earlier questions. So some terms would again get cancelled, so hence we would just skip this question also and move ahead. And we have question 4. Find an approximation of 0.99 to the power 5 using the first 3 terms of its expansion. So this is just very simple. This question is, we'll just write down, just write it once, although we've done it many times now, but we can just basically write 0.99 to the power 5 as 1 minus 0.01 to the power 5, and this can be written as, and just we can just at this point expand it using binomial theorem and use only the first 5 terms to calculate the answer. This would give us a fairly accurate answer, but like not exact, but yes, an approximate answer. So moving to question 5, expand using binomial theorem for x n equals to 0. So this question is good because here we have 3 terms. Usually in a binomial theorem problem, we usually have only 2 terms. So one very dominant approach that comes to the mind is to group 2 terms in the 3 terms, and then basically once we have grouped 2 terms, so we have only 2 terms. One is one of the 3 terms, and the second is the grouped term. So now we can apply binomial theorem on the 2 terms, and then we can apply binomial theorem individually on each of these. On the expanded version, then we can apply binomial theorem individually to each of the terms. So this is the approach to solve this question, and here it would be beneficial in if we could group the terms. Here it would be great with any of the terms. We can just take any of the 2 terms and group them. So for example, let me show an example here. So our original thing is, so maybe we can group it like this. And once we've grouped them like this, then uh, we can basically use binomial theorem on these two terms individually. One is 1 plus x by 2 and another is 2 by x. And once we have the expression, then the expression would contain powers of 1 plus x by 2, and we can expand them individually to obtain the final answer. This is slightly long, this question, and this is the way to solve it. So I think we should move on to the next question. Question 6. Find the expansion of 3x square minus 2ax plus 3a square cubed using binomial expansion. So yeah, so we can basically follow a similar approach here of grouping two terms and do it, but then it would be very tedious. So a better method here would be to complete the to factorize this whole expression, 3x square minus. So let me write it down. This expression inside the bracket, we should try to factorize it, and we can factorize it using either, or maybe we can just write it as. So this would be very difficult to separate just by looking at it, just by factoring. So we can use some more advanced formulas like completing the square or the discriminant equation in order to find out the factors of 3x square minus 2x plus 3a square, and then we can solve it further. We'll have two brackets, two linear terms, each would be raised to the power. So suppose this gets factorized to x minus a cube and x minus b. Suppose this gets factored to x minus p cube and x minus q cube, then we can individually expand these two terms, and we can then multiply the expanded terms, and this would give us our final answer. It is much easier in this case to factorize the terms first and then solve for them further. In fact, I think this could be done for the previous question as well. So in the previous question, we could follow a second approach as follows. So second approach here would be to multiply this whole terms, this whole bracket inside by x. So suppose we were to write, and here we write inside the bracket. So as we see, we have taken out x from the bracket, and hence we have multiplied inside by x and taken out 1 by x from inside, and it would be raised to the power 4. And one can see that the expression given to us and this are equivalent to each other, and hence we can also write this as x plus we can multiply this whole expression by 2 to obtain 2x plus x square minus 4x, and hence we'll have to divide by 4, and it would basically mean this. So you could see that these both expressions are also equivalent. We've taken out 2 from the 1 by 2 from the bracket and multiplied by 2 inside the bracket to obtain 2x plus x square by 2 minus 4x. And similarly, one could factorize this. Did I make a mistake? Okay, I'm sorry for this. Yeah, so one could factorize this x square plus 2x minus 4, and then we'll again have a form of x minus p, x minus q, where we can individually expand both of them and then multiply them, and we would always have x to the power 4 in the denominator, and that can be handled at the very end. So I think with this we have finished the problem set for the binomial theorem. So let us just revise a few basic approaches that we discovered today. So questions 1 to 5 were just applications of binomial theorem to get us to firm our hand on just on the application of binomial theorem. The question 6 to 9 taught us that if we have so we are basically very the powers of 10 can be very easily computed. So if a number is very close to some power of 10 and it has been raised to another power, then binomial theorem can be very useful in such cases. For example, we could write 101 to the power 4 as 100 plus 1 to the power 4. So this is what question 6 to 9 taught us. Question 10 was also very good in that we had to make one observation that we could write 1.1 to the power 10,000 as 1 plus 0.1. Again, uh, an integer, which is a power. So though technically 1 is not a power of 10, but yeah, 1 is also, it is very easy to compute the powers of 10 because powers of 1 because it's just 1. So yeah, we can just write 1 plus 0.1 to the power 10,000. And if we only notice the first two terms of this expansion, then we see that they are already greater than 1,000, in fact greater than 1,001. So definitely they are greater than 1,000, and this observation helped us to solve this question, which otherwise without binomial theorem it is very, on the face of it, it seems difficult to find out which of them is greater, 1.1 to the power 10,000 or 1,000. Again, questions 11 and 12 taught us that yeah, some terms can be cancelled, the even and odd terms. So basically root 3 minus root 2 and root 3 plus root 2, both raised to some power. They would have the exact terms in terms of the absolute values, but yeah, the signs of the terms with the odd powers of root 2 would have a negative sign. Again, question 13 taught us that yeah, so question 13 taught us a very fundamental thing, that if we are to show that some expression which contains a binomial expansion, a possible binomial expansion is if we have to show that it is or it is not divisible by some number, then we could separate all the terms which are not divisible by that number and try to adjust them with the other terms in the expression. If they get adjusted, then it becomes very easy for us to reduce further. And we took two examples in this, divisible by 8 and divisible by 64. Then miscellaneous exercises, they were very similar to the earlier questions. Yeah, and question 14, I'm sorry. So question 14 just taught us how we can write NCR to the power into 3 to the power r as NCR into 3 to the power r into 1 to the power n minus r, because multiplying by 1 does not change anything. But this brings us to the familiar form of the binomial expansion, and thus we could write it as 4 to the power n. For those who are familiar with permutations and combinations, this expression summation 3 to the power r NCR also has a meaning in terms of the combinations, but combinations and permutations, but I would not like to go into that now because it would deviate us. So coming to miscellaneous exercises. So yeah, question 1, after we used the hint, it was very much similar to question 13, and hence we had already done that, so it should have been very easy for us. Question 2 was also very similar to earlier questions, and same could be said for earlier questions. Just one thing to note in question 4, and this is in general, is that and I think that binomial theorem can be used for approximating various calculations, and this would be very useful to you in general as calculations in physics and other fields also. Question 5 and 6 basically taught us how we could. So question 5, I feel it was practically better to use the approach of grouping, but yeah, we could also just factorize if it is a quadratic or any expression, we could factorize it, and then by basic laws of exponents, the power would be given to each of the factors. And this is also another approach for simplifying expressions. So I think with this, we have completed the chapter. Thank you so much.